These are the answers to Unit 2 Multiple Choice Quiz A. As you can see, there were 5 problems that gave people the most trouble. By now you know the routine. Pause, try it again, watch the answer. First question gives you a trigonometric function and asks at which of the following points of the graph of f could the instantaneous rate of change equal the average rate of change on the interval a to b. So the first possibly confusing part for this one is that a and b are used both in a lowercase and an uppercase situation. The interval is lowercase a to b, which is down here, not capital A to capital B. If you take the lowercase a to b and connect those points with a straight line, you get this blue line here, which slopes at the 4 points match closely to the blue line. Well, A is a horizontal tangent and D is a negatively sloped line, so it's between B and C. I think C is too sharp and B looks like it could be parallel to the blue line, so the correct answer is B. Next one asks you to figure out which of the following statements can be used to conclude that f of 3 exists. So this question is focusing in on the relationship between continuous functions, differentiable functions, and whether or not a function value exists. Just because a limit exists doesn't guarantee that the function value exists, so the first one is out. If a function is continuous, then the left-hand limit, the right-hand limit, and the function value are all the same. And if a function is differentiable, then it had to be continuous. So options 2 and 3 are the ones that guarantee that f of 3 exists. So the correct choice is C, 2 and 3 only. So for this one, you're given a piecewise function, and you'd like to know which of the following statements is true. There's another question about continuous and differentiable. The best thing to do is figure out what happens at the conversion between the first branch and the second branch. If I take the limit as 2, as you approach 2 from the left, you're going to use the top branch. Substituting in, you get 10. If I take the limit as I approach 2 from the right, you're going to get the bottom branch. Substituting in also gives you 10, which means that the function value at 2 is equal to 10 because you plug into the top branch. Since both limits and the function value are all 10, the function is continuous at x equals 2. To check for differentiability, take the derivative of your f function, which is over here in red. The derivative of the top is 4, the derivative of the bottom is 3. These two do not match at 2, so it is not differentiable at 2. Choice B is the best option. It is continuous, but not differentiable at x equals 2. For the fourth one, you're given an f prime plot, which means you have the slopes of the tangent lines, and you're asked to find the equation of the line tangent to the graph of f at x equals 2. So again, start with point slope form. If they give you the point 27, you can go to the f prime plot, plug in 2, figure out that the derivative has a value of 4 at that spot, so that's the slope of your tangent line. Combine the point with the slope, point slope form, but they want your answer in slope intercept form, so solving for y produces 4x minus 1, or choice B. And for the last one, they give you an f plot, tell you that there's a vertical tangent at x equals 3, horizontal tangents at x equals 2 and x equals 4, and asks you to find the false statement. The danger with questions like this is not recognizing or remembering that they're asking you to find a false statement. Sometimes people read multiple choice, find a true one, and then immediately circle that and go on. But the idea is that there's going to be 3 true and 1 false, and it turns out that the last one is the false one. So evaluating these one at a time, is f not differentiable at 3 because of a vertical tangent? Correct. Is f not differentiable at -2 and 0 because f is not continuous at -2 and 0? If you look at the yellow locations, correct and correct. Is f not differentiable at -1 and 1 because the graph has sharp corners at -1 and 1? Yes, there's a cusp at -1 and +1. So the last one, f is not differentiable at 2 and 4 because the graph has horizontal tangents. Horizontal tangents just means that the first derivative equals 0. So that statement, not differentiable, is false. This and this are acceptable. So that's it. Hopefully those all make sense. If not, go back and review them again or use your notes. I don't have a great picture for the last screen, but I'll just give you a smiley face and send you on your way.